Hello, good people, hello. Let us begin a journey to the far side of the moon, how a Chinese spacecraft revealed the secrets of Earth's satellite on December 8, 2018. The spacecraft Chang'e 4 was launched toward the moon and later became the first in history to land on the far side of the satellite. Thanks to the mission, scientists learned what the part invisible from Earth looks like and how it is structured. On December 8, 2018, the Chinese interplanetary station Chang'e 4 set off for the far side of the moon. A Long March 3B rocket soared into the night sky, carrying a lander and rover to a region where no station had ever been before. This launch became the culmination of many years of engineers' work and opened a new chapter in the exploration of the hidden hemisphere of our satellite. The far side of the moon remained unknown until 1959, when the Soviet station Luna 3 transmitted the first images of the invisible hemisphere. It turned out that this part of the satellite lacks lunar seas. Instead, there are dense crater fields and ancient terrain that has endured far more impact events. But Luna 3 merely showed the surface for the first time. Full-scale research, including landing and soil study, became possible only with the development of relay communication and automatic navigation. After nearly a month of flight, Chang'e 4 made a soft landing in Von Karman crater, a region inside the giant South Pole Aitken Basin. This is one of the most ancient impact formations on the moon, making it a valuable object of study. The landing became a historic event. The spacecraft reached a side where no direct radio signal from Earth can arrive. The crater is named after Theodor von Karman, founder of the School of Aerodynamics, symbolically linking the mission with the scientific legacy of the 20th century. The relay satellite, Kukiao, and communication via the L2 Lagrange point. The main technical difficulty was the absence of direct communication. To overcome this, China launched the satellite Kukiao, placed in the vicinity of the Earth-Moon L2 Lagrange point of the Earth-Moon system. In this region, the satellite steadily sees both Earth and the far side of the moon, ensuring data transmission. This solution became the key condition for the successful landing and operation of the rover. What the Chinese spacecraft found on the far side of the moon, the rover Yutu-2 became the first lunar rover in history to operate on the far hemisphere. Its equipment included ground-penetrating radar and a spectrometer, which made it possible to study the composition of the soil and subsurface layers. One of the most important results was the discovery of minerals characteristic of the moon's mantle. This confirmed the hypothesis that the giant impact which formed the South Pole Aitken Basin could have ejected material from deep within to the surface. Scientific results of the mission: minerals from the depths of the moon. The spectrometer of Yutu-2 detected rocks containing minerals that usually form in deeper layers of the lunar interior. This became important confirmation of the idea that the impact creating the South Pole Aitken Basin may have pierced the outer crust. More ancient and deeper materials reached the surface, a rare opportunity to study the Moon's internal structure without drilling or crewed missions. Layered regolith and traces of cosmic catastrophes ground. Penetrating radar data showed that beneath the surface lies a complex multi-layer chronicle. Each layer was formed by ancient asteroid impacts that mixed the soil. These observations help scientists reconstruct the history of crater formation and understand how the surface on the far side changed over time. Cold nights and the behavior of volatiles. The lander recorded that nights here are significantly colder than on the visible side of the Moon. Under such conditions, volatile substances, for example, water retained in regolith particles, evaporate more slowly and are preserved longer. This makes the far side an interesting region for future missions that will search for resources in situ. The first sprouts on the Moon. On board the spacecraft was a small sealed greenhouse. Cotton seeds were placed inside, and soon after landing they produced the first sprouts in history on the surface of another celestial body. The experiment was short-lived. The onset of lunar night halted the plant's development. But the very fact of germination showed that even in low gravity, life can begin if the proper environment is created. Chang'e. In the context of China's lunar program, the mission became part of a long-term cycle including orbiters, landers, and sample return projects. Chang'e 5 delivered to Earth samples of young lava from the visible side, and Chang'e 6 for the first time brought back material from the far hemisphere. Future missions are aimed at studying the South Pole and testing technologies for on-site construction. The significance of Chang'e 4. For world science, Chang'e 4 combined several breakthroughs at once: the first landing on the far side, direct data on the mineralogy of deep layers, new observations of temperature conditions, and a unique plant growth experiment. That day became the point when humanity first moved from observation to full-scale exploration of the Moon's hidden surface. The mission paved the way for new programs that consider the satellite not only as an object of observation, but also as a scientific platform of the future. Moon, a new date announced for a historic flight to the Moon after resolving a fuel issue. NASA is once again counting down to the historic launch of a crewed spacecraft to the Moon. The launch of the Artemis 7 mission is now preliminarily scheduled for March 6. NASA plans to launch Artemis 2 toward the Moon on March 6, as announced during a press conference of the American Space Agency. This mission is the first crewed flight to the Moon in 50 years. The Space Launch System rocket is to send the Orion spacecraft with 4 crew members into lunar orbit. After flying around the satellite, the astronauts will return to Earth. This serves as preparation for subsequent Artemis missions, which envisage a lunar landing. Originally, the launch had been planned for February 7, then February 11. However, during a rehearsal on the launch pad, a fuel leak was detected. A repeated test on February 19 showed that the problems had been resolved. The Artemis crew has already been placed under a light quarantine, which will be tightened 5 days before launch. NASA management stated that they would like to send the astronauts as early as possible. For example, March 3. But other dates were unsuitable due to conditions. The final decision will be made next week after the final readiness review.